Hi everybody, nice to see you again for another amp dyno video. This video features a mono amplifier made by Rockford Fosgate in the year 2002. The amplifier is rated 125 watts into a 4-ohm load and 250 watts into a 2-ohm load. This amplifier is not comparable to the 1996 250M, which delivered 250 watts into 4 ohms and 500 watts into 2 ohms. It's very small, compact, and all your connectors and switches are on one side. So you have the RCA inputs, you have pass-through, you have a full frequency and low pass switch, and the low pass is adjustable from 50 to 250 Hertz. And the power series features filters with a slope of 24 dB. For every amp dyno I do, I create a power sheet you can see here in the videos, but I decided to make them available for everybody to download on my website. Just check out www.audiokeller.com/sheets.
The amplifier is connected to the dummy load, and this is a mono amplifier. I have connected a 4 ohm resistor to the outputs of the amplifier to test the continuous power, and I start with 1 kHz. Oops, clipping. We have 34.4 volts. The amplifier delivers 151 watts into a 4 ohm load. Let's have a look at the amplifier's efficiency. Here we have the idle current, and now I give full power into the amplifier. And we have 15.1 amps. The amplifier has a nice efficiency of 73.5%. Switching to 50 Hertz. Let's have a look. Oops, clipping. Seems like we have a little lower voltage. 33.6 volts. Testing with 50 Hertz, the amplifier delivers 144 watts into a 4 ohm load. Now I'm checking for dynamic headroom, 20 cycles. And I have all cycles at the same voltage level, and if they are at the same voltage level, we still have 34.4 volts. That means the same output power like continuous power 1 kHz. 8 milliseconds dynamic power test. Testing with all cycles at the same voltage level. And we are also at 34.4 volts, so we have the same output power like continuous and dynamic 20 milliseconds. With a short cycle test, 1 millisecond, and allowing this kind of distortion, here it looks okay, some weird behavior. We have a little higher output voltage, and the amplifier delivers 173 watts into a 4 ohm load. Continuous power test with 2 ohms, 1 kHz. Let's check out what the amplifier can put out at 2 ohms. Way too much. It says peak voltage 31.6 volts. That's correct. The amplifier is doing its rated output power 250 watts, but the manufacturer rated it 14.4 volts. Let's have a look at the amplifier's efficiency. 26.7 amps. The amplifier's efficiency is around 69% at 2 ohms. Continuous power test with 50 Hertz. Oops. Try to squeeze out a little more. No chance, signal goes dirty. And we have a peak voltage of 30.8 volts. That's true. With 50 Hertz, the amplifier delivers 237 watts into a 2 ohm load at 13.6 volts. 20 cycles dynamic power test. All cycles same voltage level. No clipping. Sometimes we have clipping at the first cycles. We have 32 volts. Let's observe the last cycle. Also 32 volts. 256 watts into a 2 ohm load with 20 cycles. Dynamic power test, 8 milliseconds. Clean output voltage, and we have 32.4 volts. Yeah, let's calculate with 32.4 volts. The amplifier delivers 262.5 watts into a 2 ohm load. 1 millisecond, 1 kilohertz power test, 2 ohms. We have a higher output voltage. We have 36 volts. We have 324 watts. In the test, the amplifier showed a nice efficiency of about 70% or more. So I'm going to make a 1 ohm mono test. I'm trying to do a continuous power test. It's doing some power. Oops. Try to get some more voltage. But look, this here. And we have around 20 volts, I guess. 20.2 volts. The amplifier delivers around 208 watts. We have a crest factor of 3 dB with a continuous sine wave, and music isn't a sine wave and has a much higher crest factor, which is a lighter load to the amplifier's power supply. So I expect the amplifier will do some more dynamic power. Dynamic power test, 20 cycles. I try to get all cycles at the same voltage level. Looks like they are. We have a voltage of 27.6 volts. In the center, 27.6 volts. So I go to the last one. Slightly clipped. We have 27.4 volts. I calculate with 27.5 volts as the average. Dynamically, with 20 cycles, the amplifier delivers 378 watts into a 1 ohm load. Dynamic burst power test with 8 cycles. I check the first two. And we have a voltage of 28.4 volts. I go to the last ones. We also have 28.4 volts. With 8 cycles, the amplifier delivers 403 watts. Peak power test for just 1 millisecond, but RMS peak power test. We get higher voltage. It says 33.6 volts, and I can confirm it. Just for fun, I'm doing a half-ohm mono test, so I have connected two 1 ohm resistors in parallel, and I'm going to start the test. All are at the same voltage level. That's nice, no projection is coming in, and I have 20.8 volts at the beginning, and at the end, slightly clipped here, but also 20.8 volts. The amplifier delivers 433 watts into a half ohm. Output power test, half ohm, dynamically with 8 milliseconds, and I'm starting now. All cycles at the same voltage level, no clipping here. I got 21.8 volts. volts. So I have to say the amplifier is getting warm now. The amplifier delivers 475 watts. Now I'm doing the 1 milliseconds output power test. The amplifier did not go into protection during all the tests. And we have a higher output voltage. We are at 28.4 volts. For 1 millisecond, the amplifier delivers 806 watts into a half ohm. Honestly, I have to say the amplifier got warm during the torture test. Almost too hard to touch. I don't know if the amplifier has a protection, but half ohm is not bad and the amplifier produces more power, dynamically by the way. So this little amp is impressive. I really like it for such a small mono amplifier.
In case you expect a sound test of a mono amplifier, I'm sorry I didn't do a sound test. This amp really impressed me because of the low ohm capabilities. It was great. Thank you very much for watching and see you next time for another amp dyno video. Bye bye!